All right, today we're doing something a little different. Think of it as a digital dissection. We're going to peel back that smooth metal skin of an airplane wing and really get a look at the complex anatomy hidden inside. So let's get right into it.
You know, you see them all the time, from the ground, slicing through the clouds, or maybe you're staring right out at one from your window seat. They're such a familiar sight, right? We know they're the reason this massive metal tube can actually fly. But that sleek, simple look, well, it hides a whole world of incredible complexity.
So that's the big question for today. If you could just peel back that smooth metal skin, what would you actually find in there? What's the secret architecture that lets these things handle unbelievable forces and lift hundreds of tons into the air? Okay, first things first, let's get one thing out of the way. A wing is not just a solid slab of aluminum. Not at all. In fact, it's mostly empty space. But it's that carefully designed space supported by this incredibly strong but lightweight internal framework that makes it all work. And that brings us to our first section here. We're going to look at that internal framework. And honestly, the best way to think about it is like a skeleton. A skeleton that was purpose-built to fly. And here we go, our first look inside. This diagram shows you the key parts that give the wing its shape and all of its strength. You can see these long beams running down the length of the wing, and then the cross-sections that create that classic airfoil shape. It's this amazing mix of pure engineering and something that feels almost biological. The most important parts are these things called spars. They're these really long beams running all the way from the root of the wing, right where it joins the plane, out to the tip. They are, without a doubt, the backbone of the wing. They take on all the major bending forces when the plane is in the air. Now, running across the spars, you've got the ribs. And if the spars are the backbone, then yeah, the ribs are absolutely the rib cage. They're what gives the wing that crucial curved shape, the airfoil. And they support that thin outer skin, sending all the aerodynamic forces from the skin back into the super strong spars.
So you've got all this empty space between the ribs. What do you do with it? Well, it is definitely not wasted. In most big airliners, the wings themselves are the fuel tanks. It's just a brilliant piece of design, right? It uses that space so efficiently, and it helps balance the plane by putting all that fuel weight right where the lift is being generated.
Okay, this diagram shows a bunch of cool stuff, but I want you to focus on just one detail you can see from the front view here. See how the wings aren't perfectly flat? They angle up just a little bit. That upward V shape has a name. It's called the dihedral, and it might seem like a small detail, but it is fundamentally important for keeping the plane stable.
And here's why that's so important. The dihedral gives the plane this inherent natural stability. So if a gust of wind, say, pushes one wing down, that angle helps the plane automatically want to return to flying level, all without the pilot having to constantly fight the controls. It's just a simple, really elegant piece of passive safety engineering. All right, so we've covered the static skeleton, the bones of the wing. But a wing is anything but static. It's constantly changing its shape to control the airplane. So let's move on and check out all the moving parts that make that happen.
Wow, now this looks complicated. Because, well, it is. An airliner's wing is like a symphony of moving parts. Think of this diagram as a roadmap to all the different surfaces that let a pilot maneuver a massive aircraft through the sky with total precision.
So let's break down the main tools in this kit. Out on the edges, you've got ailerons. They work opposite each other to roll or bank the plane left and right. Then you've got flaps on the trailing edge. They extend out to give you more lift and drag, which is crucial for takeoff and landing. You also have spoilers that pop up from the top to, spoil the airflow, acting like air brakes. And on the front, the leading edge, you have slats, which do a similar job to flaps, adding lift at low speeds.
But here's the thing. For all its complexity, the wing does not work alone. Nope, it has a super important partner at the other end of the plane. So let's talk for a minute about the unsung hero of flight, the tail. See, the wing's main job is just to make lift. But without the tail, or the empennage if you want to get technical, the plane would be wildly unstable. The tail is what provides the balancing forces that keep the aircraft stable and pointed in the right direction. And the empennage has two main parts. You have the vertical stabilizer. That's the big fin on top. It stops the plane from fishtailing side to side, which is a movement called yaw. It's also where you find the rudder. Then you have the horizontal stabilizer, which keeps the nose from bobbing up and down. That's called pitch. And it contains the elevator to control that up and down movement. And this is a great illustration of how not all tails look the same. On the left, you've got that classic setup you see on most airliners. But on the right, that's a T-tail. You see that a lot on planes with engines mounted on the back.
because it lifts the horizontal stabilizer up and out of the hot engine exhaust. They both do the same job, just with different engineering solutions.
So, let's bring it all back together now. You've got the internal skeleton of spars and ribs, you've got the skin that covers it all, you have the muscles, the flaps, ailerons, and spoilers that change its shape, and you have its crucial partner, the tail, providing stability. It's a complete, totally integrated system.
And in the end, it all comes down to this one simple, really powerful idea from our source material. All of this structure, all of this incredible complexity, it serves one single purpose: to transform the forward speed from the engines into the vertical lift that lets us conquer gravity.
So next time you're on a flight and you look out that window, you're not just going to see a wing anymore, are you? You'll see the spars inside, taking the load. You'll picture the ribs holding that perfect shape. You might even think about the fuel sloshing around inside, and you'll see that complex dance of all the control surfaces. You'll be seeing the true anatomy of flight.